Viewers, welcome to add-on. In this question, we are asked to find the gray code of the decimal number 8, and these are the four options which are given to us. So let us start with the solution. So the decimal number 8, we can represent it in binary number system. Okay. So for binary number system, we know that the positional weights for each of the bits is given like this. For example, this is a 4-bit binary number. Okay. So for the absolute right hand side bit, this bit we will call it as the least significant bit or LSB, and this bit we can call it as most significant bit or MSB. Okay, and the least significant bit has a positional weight of 2 to the power 0, which is 1. And then as we move to the left hand side, the positional weight will increase by a power of 1. For example, to the bit which is present on the left hand side of the LSB, we will get a positional weight of 2 to the power 1, which is 2. Then here we will get 2 to the power 2 will be 4. Here we will get 2 to the power 3 will be 8. And likewise, as we move to the lid, we will get 16, 32, 64. Likewise. Okay. So in this case, we are asked to find the gray code of decimal number 8. And one thing, we have to select how many bits we are required to represent a particular decimal number. Like in this case, if we use 3 bits, only 3 bits, for 3 bits there will be 8 combination, right? 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So if we look at the positional weights of it, so here we will have 1, here we will have 2, here we will have 4. So if we add the positional weights with the bits and then multiply it, we will get 4 into 1 plus 2 into 1 plus 1 into 1, which will be equal to 7. So by using 3 bits, we cannot represent the decimal number 8. So in order to represent the decimal number 8, we need to use minimum of 4 bits. Okay. So for 4 bits, what do we need to do? As we have already know, these are the positional weights which are given to us. So in order to represent 8, we will just write 1 in the place of 8, and our requirement is completed here because we need only decimal number 8 in binary number system. So we will write the bit 1 for positional weight of 8, and we will write 0 for the rest of the cases. And if we want to check that if it does represent the decimal number 8, we can simply check it by multiplying the positional weight with the bit they are associated with it, and then we can add them together. Like here it will be 8 into 1 plus 4 into 0 plus 2 into 0 plus 1 into 0. All these cases will be equal to 0, and 8 into 1 will be equal to 8. So yeah, this binary number 1000 will represent decimal number 8. Now the main question is how we can convert this binary number into its gray code. So the conversion rule is pretty simple. Like this is the binary number which we have derived 1000. So to write its gray code, we will start like this. For the most significant bit, as I have mentioned earlier, will be the bit on the absolute left hand side. So we will write this bit 1, and then what do we need to do? Then we will XOR these two adjacent bits. 1 and 0 will be XORed together. Then the next two adjacent bits will be XORed together. 0 and 0 will be XORed together, and the next two adjacent bits will be XORed together. 0 and 0 will be XORed together, and this 3 result we will write it alongside with 1, and this will be our equivalent gray code. For better simplicity, we can also say that this is the binary number. So what we are going to do is we are writing 1, then we are XORing 1 and 0, so that will give us 1 XOR 0 will be 1. Then we are XORing 0 and 0, so that will give us 0, and then we are again XORing 0 and 0, that will give us 0. So the main principle is we will just write the most significant bit at first, then we will just XOR the adjacent bits, and we will write it alongside this bit which we have written here. Okay, so here in this particular scenario, we have written the most significant bit of 1, then we are XORing the two adjacent bits which will give us 1. We will write it alongside with the most significant bit. Then we are XORing 0 and 0 which will give us 0. We will write alongside this 2 bits, and then at last we are XORing 0 and 0 which will give us 0. So this is our equivalent gray code of this particular binary number. and in this case it will be our option number A. Thank you.